Uranus is the seventh planet from the Sun and is full of mysteries. Unlike any other planet, Uranus spins on its side. Imagine a planet rolling like a ball along its path around the Sun. That's Uranus. This unusual tilt fascinates astronomers and space fans. Uranus is an ice giant with a thick atmosphere made of hydrogen, helium, and methane. Methane gives Uranus its blue-green color, showing how cold it is. Temperatures can drop to minus 371 degrees Fahrenheit. Winds can blow at speeds of up to 560 miles per hour. Uranus is a planet of extremes, both beautiful and scary. Why does Uranus spin on its side? This question has puzzled astronomers for centuries. The most likely explanation is a cataclysmic event early in the solar system's history. Billions of years ago, when the planets were still forming, a massive object, perhaps a planet the size of Earth, or even larger, collided with Uranus. This collision was no ordinary fender bender. It was a cosmic smash-up of epic proportions. The impact of this collision sent shockwaves through the young Uranus, tilting its axis of rotation dramatically. Imagine a spinning top being struck by a marble. The force of the impact would knock the top off its axis, sending it tumbling in a new direction. This is likely what happened to Uranus, but on a much grander scale. The impact would have also created tremendous heat and energy, melting and vaporizing much of the ice and rock that made up the young planet. This material would have been flung into orbit around Uranus, eventually coalescing to form the planet's rings and moons. The evidence of this ancient collision is written all over Uranus, from its tilted axis to its complex system of rings and moons. Uranus is a very different place from Earth. While Earth is a rocky planet with a relatively thin atmosphere, Uranus is a giant ball of ice and gas. Deep beneath its thick atmosphere lies a slushy ocean of water, ammonia, and methane. This strange ocean is unlike anything found on Earth. The intense pressure and lack of sunlight create an environment that is both exotic and hostile. Above this hidden ocean lies Uranus's atmosphere, a turbulent mix of hydrogen, helium, and methane. The methane in Uranus's atmosphere is what gives the planet its distinctive blue-green color. Methane absorbs red light from the sun, reflecting blue and green light back into space. This gives Uranus its serene and almost ethereal appearance. But don't let the calm colors fool you. Uranus's atmosphere is anything but peaceful. Winds rage at hundreds of miles per hour, creating massive storms that can engulf the entire planet. These storms are driven by the planet's internal heat and its rapid rotation. Uranus is a world in constant motion, a swirling vortex of ice, gas, and wind. Uranus's unique atmosphere. Uranus's atmosphere is a fascinating and complex place. It's divided into several distinct layers, each with its own unique characteristics. The outermost layer, the stratosphere, is a hazy region where temperatures are relatively warm. This warmth is due to the absorption of ultraviolet radiation from the sun by methane and other hydrocarbons. Below the stratosphere lies the troposphere, the densest and most active layer of Uranus's atmosphere. This is where the planet's powerful winds and storms are generated. The troposphere is also home to Uranus's clouds, which are thought to be composed of ammonia ice, water ice, and methane ice. Deep within the troposphere, the pressure and temperature increase dramatically. At these depths, the atmosphere transitions into a supercritical fluid, a state of matter where the distinction between gas and liquid blurs. This bizarre fluid is thought to make up a significant portion of Uranus's interior. Exploring the depths of an ice giant. Exploring Uranus is a daunting task. Its extreme distance from Earth, combined with its harsh environment, makes it one of the most challenging targets for space exploration. Despite these difficulties, scientists are eager to learn more about this enigmatic ice giant. A mission to Uranus could provide invaluable insights into the formation and evolution of giant planets, as well as the conditions in the early solar system. One of the most intriguing aspects of Uranus is its internal structure. Scientists believe that Uranus has a small, rocky core surrounded by a thick mantle of water, ammonia, and methane. This mantle is thought to be in a supercritical fluid state, meaning that it behaves like both a liquid and a gas. A mission to Uranus could investigate the composition and structure of this mantle, providing clues about the planet's formation and evolution. Scientists are also interested in studying Uranus's magnetic field, which is tilted at a significant angle to its axis of rotation. This unusual magnetic field is thought to be generated by the movement of electrically conductive fluids in the planet's interior. Voyager 2, a fleeting glimpse. Our only close-up view of Uranus came from NASA's Voyager 2 spacecraft, which flew past the planet in 1986. Voyager 2's encounter with Uranus was brief, but it provided a wealth of information about this distant world. The spacecraft's instruments revealed the planet's complex ring system, its many moons, and its surprisingly dynamic atmosphere. Voyager 2 also captured stunning images of Uranus's clouds, revealing a banded structure similar to that seen on Jupiter and Saturn. These bands are thought to be caused by differences in temperature and altitude in the planet's atmosphere. Voyager 2's observations also revealed the presence of powerful winds and storms in Uranus's atmosphere, some of which were larger than the entire Earth. Despite its many discoveries, Voyager 2 only scratched the surface of what there is to learn about Uranus. The spacecraft's flyby was brief, and its instruments were limited by the technology of the time. A dedicated mission to Uranus, equipped with more advanced instruments, could revolutionize our understanding of this enigmatic ice giant. The future of Uranus exploration. The future of Uranus exploration is full of possibilities. Scientists are developing new missions to Uranus that could launch in the coming decades. These missions would have advanced instruments to probe the atmosphere, map the surface, and study the interior. One concept involves a spacecraft orbiting Uranus for years, studying its atmosphere, magnetosphere, and rings. It could also deploy probes to measure the atmosphere's composition and weather patterns. Another concept is sending a lander to one of Uranus's moons, like Titania or Oberon. These moons may have subsurface oceans of liquid water. Exploring Uranus is challenging but rewarding. Unlocking its secrets could provide insights into our solar system's formation and evolution. As technology advances, we move closer to unlocking the mysteries of Uranus, the tilted planet.